Okay, so in this video, I'm going to take a look at how you can determine the products of a double displacement problem, assuming that they're both ionic compounds, and you can figure out the charges. Okay, this goes back to an idea that we talked about last semester in terms of ionic compounds. The idea is that any ionic compound is made up of a cation, in other words, a substance that has a positive charge, and an anion, a substance that has a negative charge. The cation is always the first substance in the ionic compound formula, and the anion, or the negative substance, is always the second element or substance in the formula. So in this case, we have gold sulfide. Gold is the positive ion, or cation, and sulfur is the negative. The other substance that we have here, hydrogen sulfate, or sulfuric acid, the hydrogen is the cation, or positive substance, and the sulfate is the anion. Now, the next thing we need to figure out is we need to figure out what are the charges of each of the ions. What are their actual charges? Well, if we start with the first compound on the left, well, gold is a transition metal, which means we don't know its charge just by looking at the compound. Sulfur, on the other hand, we do know. It's a nonmetal. Nonmetals always have the same charge every time they form an ion. So in the case of sulfur, based on where it is on the periodic table, its charge will be -2. So one ion of sulfur has a charge of -2. But we have 3 of them. So if you have -2 charge for each of those 3 ions, that means you have a -2 times 3 ions, or a -6 charge for this side of the compound. Now, the charge of the total compound, if we put it all together, has to have a charge of 0. What that means is the positive charge over here needs to be equal or opposite to the negative charge on this side, so that they both add up to equal 0. In other words, the total charge of the gold ions needs to be +6, because +6 added to the -6 on the right-hand side of the compound will give us a total charge of 0. Now, what that means is we can take this +6 charge and we can divide it between the 2 golds. And if we do that, that means that each gold has a charge of +3. There we go. We have our charges for the first compound. Now let's do the second compound. Okay? If you remember your polyatomics, you'll know the charge of the sulfate. But let's say that you've forgotten it. If you've forgotten it, we're going to start with the hydrogens, because hydrogens have a known charge. Hydrogens, when they form an ion, will have a charge of +1. We have 2 of them, right? So +1 for each hydrogen ion, 2 ions, gives us a total charge of +2. And just like with the first compound, the total charge of the compound needs to add up to be 0. If that's the case, that means that the sulfate has to have a charge of -2. And we only have one sulfate, which means that this one sulfate will get the full negative charge, or the full -2. Okay? Now, why did I need to do all this? Well, it turns out that when you have a double displacement problem, we know it as a swap problem, meaning that's the nickname, right? All that means is the gold, or the cation of one compound, is going to pair up with the anion of the other compound, like so. And the anion of that first one is going to pair up with the cation of the second compound, like so. Okay? But we need to know their formulas, right? Again, going back to last semester, that means that we need to actually swap and drop the charges to create the new chemical formula that has a neutral charge. So in the case of the gold and the sulfur, we have a gold with a charge of +3, and we have a sulfate with a charge of -2. If we swap and drop that, it means we're going to end up with gold. We swap the charge from the sulfate, which was -2, we swap it and we drop it down to a subscript. And then we have the sulfate. We swap the charge from the gold, which is +3. And since this is a polyatomic, we're going to give it parentheses. We drop that +3 down as a subscript. So it's going to be Au2SO43. Okay, that's our gold sulfate. Now in the case of the sulfur and the hydrogen gas, hydrogen has a charge of +1, sulfur has a charge of -2, so to swap and drop, the hydrogen will get the charge of the sulfur as a subscript, so that would be the 2. We swap it and drop it. And then the sulfur, or sulfide, since it's part of an ionic compound, will get the charge of the hydrogen dropped as its subscript, but because it's a subscript of 1, we don't have to write it. So if we combine the original reactants of gold sulfide and sulfuric acid, we would expect, if this is a double displacement problem and it makes products, we would expect to see gold sulfate and hydrogen sulfide, and these would be the formulas.